let's talk about sampling and data. So firstly, we'll go on to data and the different types of data. So the types of data are qualitative, quantitative, discrete, and continuous. So a qualitative piece of data is some data that's descriptive. So it could be something like a colour, for example, maybe a name, things like that. So descriptive data. Quantitative, on the other hand, is numerical data. So something that would be given a numerical value. So you could have weight for that, like height, something like that. Something that would have numbers as its answer. Discrete data is data that is fitted into categories. So that might again be colour, because you're either blue, red, yellow, whatever. And then continuous is kind of, as it says, it's continuous, so it can take any value in a range. So it could be like weight, again, height. Discrete tables have gaps in, so for example, they could fit into 0 to 1 and then you go 2 to 3, whereas continuous, it wouldn't have a gap. So discrete has gaps, continuous wouldn't have a gap. That would be something along the lines of that. So as you can see, so x can equal 0, doesn't equal 1, but it does equal 1 there. So there's no gaps in continuous data, so it can take any value in the range, but you do have gaps in discrete data. Now we'll look at the idea of sampling. What is sampling? So sampling is when you take a small piece of the population. And the reason you might do this is if you think of the whole population that you're trying to sample, sometimes it might be huge. So if we take, for example, the UK, you can't really ask everyone the same question and get an answer because there are like billions of people. So that's not going to work. So the way we do this is we take a sample. So a sample is a small bit of the population that can represent fairly the bigger population it's trying to replicate. So sampling must be fair. So the sample you pick to represent your wider population must be a fair sample, and that is so that the data can be accurate. There are examples where it's biased, and then it might be biased towards men, and then you don't get accurate data for females and things like that. So to make it fair, there are two things you have to do. You must make your sample random. And by that means that when you're picking people out of a population, you're not picking them for any reason, it's just completely random. So everyone has an equally likely chance of being in the sample. Your sample must also be big enough so it's fair, because if I just took one person to represent the whole population, that's not going to be big enough. Even if I took two, again, that's just going to be like two people's information. That doesn't represent everyone, so you have to take a big enough sample. And this is really important in daily life when you're looking at adverts and when people are trying to sell you things and they say statistics, so like 90% of people who tried this product said this, and you have to be really careful that they're picking a big enough sample, because that might be 90% of like their 10 best friends that they've told to give it a good rating. So you've got to make sure that it's big enough and that it's random. So for example, you're not using people's best friends or anything like that. And this is really good in data analysis and daily life to pick out like the lies and statistics that we hear a lot these days. A way a sample would work is if I took a sample of a population and I got 90% of the sample like Taylor Swift. Assuming that my sample was fair, so it was random and it was big enough, then I could say that that is an accurate representation of my whole population, so I could kind of expand that to say 90% of the population like Taylor Swift. So, you know, I feel like this is pretty accurate. Let's say we were going to create a simple random sample. How would we do that? So the first thing you would do to create a simple random sample would be to number everyone in the population. The second step would be to get a list of random numbers, so maybe use a random number generator, something like that. Pick random numbers and then take those people that you'd given those numbers to in the population and use them as your sample. So basically what you've done there is, as long as you do a big enough sample, that's really good because it's completely random. So everyone's been given a number, you randomly generate a list of random numbers and you pick those out of the population. So everyone is equally likely to get picked, and hopefully you're using a big enough number. Sometimes it's really important, especially nowadays in the media and stuff like that, to spot a problem or like spot bias when people are trying to like say stuff and they've done some statistical study. So you need to be able to be quite like savvy and be able to spot bias. So the questions you're going to ask yourself when you're trying to spot bias and see if this like study is accurate and fair is when, where, how, and how many. Okay, so these are all really good questions to ask. So an example of bias might be if I was asking people the question like, oh, do you play rugby? And then maybe I took a sample, but most of my sample, so 90% of my sample were all men. Therefore, I might have a gender bias because I'm not really representing the female's opinion on whether they play or like rugby properly. So therefore, I have a gender bias. You might end up having things like an age bias. So if you were going to ask people what type of music they listen to, and you only ask young people, like maybe you need to ask the older generations because it doesn't accurately represent the population. But the population doesn't necessarily have to be the UK, the world. You have to specify the population and then sample from that specified population of people. So if I was asking what type of music you like, and I set it out from the start, what type of music do 12 to 25-year-olds listen to? And I asked enough random people of all those different ages in that category, that's accurately representing the population. So in that example, I don't need to go and ask 50-year-olds because that's not in my question. I need to get enough of each age within the population, and in that case, that would be 12 to 25-year-olds.